Hello students, I'm Dr. Sumit Majumdar. I'm a pass out of IIT Delhi. I'm from the 2003 batch. Since then, I am with askIITians. Today, we'll be discussing about electrostatics. Why exactly this is important? As the name itself suggests, electrostatics. Electro stands for electrons, statics means at rest. So let's try and understand about electrostatics in this particular topic.
Hello students, today we'll be discussing about electrostatics, electric charges and fields. So let's understand about that. Now when we try to talk about electrostatics, electric charges and fields, so what is the basic thing that comes into the picture? Or why do we need to understand about this? Have you ever wondered, supposing you comb your hair and then you try to take your comb near some bits of paper, what you see? You find that those pieces of paper get attracted to the comb. Have you ever wondered why? The reason behind that is nothing but electrostatics. It's a very simple concept based on which many things are actually devised. So let's now understand what basically does electrostatics stand for. So electrostatics is nothing but the branch of physics which deals with the forces that are exerted by a static. Please understand, when we talk about electrostatics, it is the static charge and the static electric field that is produced. Now, most important thing to understand here are that there are two types of charges. We have one charge that is defined as a positive charge, the other charge that is defined as a negative charge. And it's always going to be true, like we have opposite sexes getting attracted towards each other. Similarly, we have opposite charges getting attracted towards each other. This is the only difference, if you'll actually like to say, with regard to the gravitational field. This is the only difference from a gravitational field with regard to the electrostatic field. Gravitational field always attracts because there is just one type of mass. Masses are always going to be attractive, whereas when we talk about charges, there are two types of charges, therefore we have two types of forces. One, an attractive force, one, a repulsive force. Okay, so let's try to understand more about the charges. So what exactly is a charge? As we know, every object that we see around us has mass. It occupies space. In a similar manner, charge is also an intrinsic property of the matter that surrounds us. Okay, so it's an intrinsic property. There are two types of charges. One is a positive charge, which is because of the protons that exist. Next one is a negative charge, that is because of the electrons that exist. And opposite charges subtract each other and the lights are going to repel each other. If we talk about an explanation, why or how does this actually take place? As we know, in an atom, you will have a nucleus. The nucleus would have protons, it would have neutrons, and it would have electrons. Now, the protons and the neutrons occupy a very small region of space, right? That means when we are saying that the opposite charges are going to attract and the lights are going to repel. So in this particular small region of space, if we have the protons, that means shouldn't they be repelling each other? But we know that the atoms are stable and the nucleus is a very small integral part of the atom. So what is the thing that keeps the protons intact in such a small region of space? It is the strong force. It's a strong nuclear force. It's not the electrostatic force, mind you. There is a force of repulsion that exists between protons, but here we also have the strong nuclear force, which is the strongest force that exists. So that strong force overcomes the electrostatic force of repulsion that exists between protons, and this nuclear force is uniform. It does not differentiate between a proton and a neutron. It is the same between two consecutive neutrons, it is the same between two consecutive protons, as well as one proton and one neutron. Because of this reason, we always are going to define the charges, whether the positive charge or the negative charges, in terms of electrons only, because the protons are not going to be transferred. Yeah, electrons are the lightest They have a mass of the order of 9.1 into 10 raised to the power minus 31 kgs. If we talk about protons, they are of the order of 1.67 into 10 raised to the power minus 27. So roughly around 10,000 times heavier are the protons as compared to electrons. That means any kind of interaction that is going to be produced is going to be because of electrons. Either there is going to be an addition of electrons which is going to increase the negative charge, or there is going to be a reduction of electrons that is going to result into a positive charge. So deficiency of electrons means a positive charge, excess of electrons means a negative charge. Now let's try to understand about this further. Here, positive charge center nucleus is of the order of 10 raised to the power minus 15 meters. This is what? This is the size of the nucleus, because the nucleus would have positive charge. Why? Because neutrons are neutral, protons are positive charge. So effectively, the nucleus has to be having only positive charges. There cannot be any electrons residing within the nucleus. Therefore, this is what we have is the size of the nucleus, and this is the size of the atom as a whole. Now let's try to do an example to understand it further. What we are going to do here, the experiment, is that you rub a glass rod with the help of a silk cloth. Once you rub it, and then you rub another rod with the help of the same silk cloth, what you are going to see now is an actual example of repulsive force. As you can see, the other glass rod just fell down, but again, if you try to place that glass rod, you'll see that there is a kind of repulsion. The other glass rod is just trying to move away. Why? Because of this repulsive force, right? So this is an example of the repulsive force that actually exists. Now let's move on. As I mentioned, any atom is going to be consisting of these types of particles. So this is nothing but your nucleus. So if we now put in the types of particles that are there, so we have the electrons here, we have the electrons, we have the neutral particles, that is the neutrons, and the protons. These are the basic building blocks that exist. Now, in a neutral atom, from a neutral atom, let's say you remove an electron, as I mentioned, you're going to get a positive ion. It's not going to be an atom anymore because it has charges. Similarly, if we move further, but before that, let's understand that each electron would have a charge of minus 1.602 into 10 to the power minus 19 coulombs. This is the fundamental unit of charge. So fundamental building blocks of any matter are atoms. Similarly, neutral atoms, if you add an electron, you're going to get a negative ion. So here, if I talk in this particular sense, you can see that the total number of red colors and the total number of blue colors are exactly the same. The numbers are the same. That means this particular object will not have any overall charge. It's going to be charge neutral, right? So in the neutral object, what we have, the number of electrons is going to be equal to the number of protons, right? Moving on, if you do transfer some charges, then either it's going to become positively charged or it's going to be negatively charged. So when electrons are removed, you will have something like this. When electrons are added, you will get something like this. So this is the negatively charged object on the right and the positively charged object on the left. So this takes place due to the transfer of electrons. Now, in our next topic, we are going to understand more about how does this transfer actually take place.
So students, we learned about what basically is the basic background of electrostatics. We understood that we need to know what is an atom, what does it constitute of? It constitutes of the charges, right? So what those charges do and how do we classify them? That is, we understood about the positive charge, the negative charge, and what is results or what basically happens when you have an excess of electrons or a deficiency of electrons. That results into either a positively charged object or a negatively charged object or vice versa. Now let's try and go further and try to understand when you have two charges, what exactly is the kind of force that exists between them. So stay tuned for that.